Welcome you all. In this session, we are going to discuss in detail about transformer construction. A transformer consists of two windings coupled together on a magnetic medium. The two windings work at different voltage level. The two windings of transformer called high voltage winding and low voltage winding. Both the windings are wound on a common core. Here you can see the core of the transformer. This is what we call it as the core of the transformer. We have two windings, one is primary and another one is secondary. The primary is connected to the source and the secondary is connected to the load. Usually it may be a step up or step down. So any one of the winding will be a high voltage and another one will be a low voltage winding. So here it is taken as this one as the primary winding and the other one as secondary winding. So we know that always a transformer works on AC source. So this is the iron core of, there are various types of cores and we are going to discuss in detail about various types of transformers and various types of cores we have in transformer. A transformer consists of two windings coupled to a magnetic medium. The two windings work at different voltage and the two windings of transformer are called as the high voltage winding and low voltage winding. Both the windings are wound on a common core. One of the winding is connected to the AC supply, it is called as the primary. The other winding which is connected to the load, we call them as secondary. The transformer is used to transfer electric energy from one circuit to other circuit without any change in frequency. So this is the major function of a transformer. The construction of transformer varies greatly depending on their application, winding voltage and current rating and the operating frequencies. The two major types of construction of transformers are core type and shell type. Based on construction details, there are two types, core type and shell type. Depending on the application, these transformers are classified as distribution transformer and power transformer. Distribution transformers and power transformer. The transformer is extremely important as a component in many different types of electric circuit, from small signal electronic circuit to high voltage power transmission system. The most important function performed by transformers are changing voltage and current level in electric system, matching source and load impedance for maximum power transfer in electronic and control circuitry, electrical isolation. These are the major tasks a transformer performs. Core type transformer. In core type transformer, the magnetic core is built of laminations to form a rectangular frame, and windings are arranged concentratedly with each other around the legs or limbs. The top and bottom horizontal portion of the core are called yoke, and the yoke connect to two limbs and have a cross-sectional area equal or greater than that of limb. Each limb carries one half of primary and secondary. The two windings are closely coupled together to reduce the leakage reactance. The low voltage winding is wound near the core and the high voltage winding is wounded over the low voltage winding away from the core in order to reduce the amount of insulating material required. Usually near the core the low voltage winding will be wounded, and over that after insulation the high voltage winding will be wounded. So from the core the high voltage winding will be away, whereas the low voltage winding will be much closer to it. So the shell type transformer, in shell type transformer the windings are put around the central limb and the flux path is completely through two sides of limb. The central limb carries the total mutual flux, while the side limbs form a part of parallel magnetic circuit, carry a half and total flux. The cross-sectional area and central of the central limb is twice the each side of limb. Comparison of core and shell type transformer. Core type transformer, easy in design and construction. Shell type transformer is comparatively complex to that of core type. And in core type transformer has a low mechanical strength due to non-branching of wings. Here high mechanical strength in case of shell type transformer. In core type transformer, reduction of leakage reactance is not easily possible, but in shell type transformer, reduction of leakage reactance is highly possible. In core type transformer, assembly can be easily dismantled for repair work, whereas here it is little bit tough in shell type transformer. In core type transformer, better heat dissipation from windings. In shell type transformer, heat is not easily dissipated from the windings since it is surrounded by the core. In core type transformer has longer mean length of core and shorter mean length of coil turn, but it is opposite in case of shell type. So here it is used in extra high voltage system. It is not suitable for extra high voltage system, shell type transformer. So this is a major comparison between the core type and shell type transformer. So the next one is distribution transformer and power transformer. Based on application point of view, it can be classified into two. One is distribution and another one is the power transformer. So first let us discuss in detail about the distribution transformer. Transforms up to 200 kVA are used to step down distribution voltage to a standard service voltage, or from transmission voltage to distribution voltage are known as distribution transformer. They are kept in operation all the 24 hours a day, whether they are carrying a load or not. The load on the distribution transformer varies from time to time, and transformer will be on no load most of the time. Hence, in distribution transformer, the copper loss will be more when compared to core loss. Hence, distribution transformers are designed with less iron loss and designed to have a maximum efficiency at load much lesser than full load. Also, it should have good regulation to maintain the variation of supply voltage within limit, and so it is designed with small value of leakage reactance. Power transformer. The transformers used in substations or generating stations are called power transformer. They have a rating above 200 kVA. So below up to 200 kVA we use it in distribution transformer. Here the power transformer, it has a rating more than 200 kVA. Usually substation will have a number of transformer working in parallel. During heavy load periods, all transformers are put into operation, and during light load, some transformers are disconnected. Therefore, the power transformers should be designed to have maximum efficiency at a near full load. Power transformers are designed to have considerably greater leakage reactance that is permissible in distribution transformer in order to limit the fault current. In case of power transformer, inherent voltage regulation is less important than the current limiting effect of higher leakage reactance. Thank you.